Hello students, I am JV Sirionchi sir from MSG College. In previous video, we discussed about some theoretical points of protection and deprotection. In today's lecture, we discuss about protecting groups for alcohol. The first group is acetal or ketals as a protecting groups for alcohol. As we know that acetals and ketals are the protecting group from aldehydes and ketones, but they are not only useful for the protection of aldehydes and ketones, they are also useful for the protection of alcohols. For example, this is the dihydropyrin. This dihydropyrin, when react with this alcohol in presence of acid, it forms THP, tetrahydropyranil. Okay, these all the tetrahydropyranil derivative are deprotected by aqueous acids. Aqueous acids means H3O plus, and we again get our alcohol. Therefore, this dihydropyrin acts as a protecting group, and this aqueous acid acts as a deprotecting group for alcohol. The second one is methoxy-ethoxy-methyl chloride. This is methoxy-ethoxy-methyl chloride. This react with alcohol to form MEM derivative, means methoxy-ethoxy-methyl derivative. This is also deprotected by any aqueous acid, and we again get our alcohol. For protection we use the methoxy-ethoxy-methyl chloride, and for deprotection we again use aqueous acid. Similarly, alcohol is also protected by methoxy-methyl chloride. It will react with this alcohol, it forms methoxy. This is methoxy-methyl derivative of alcohol. Ether. This is actually derivative of ether. This is also ether. Okay, when at aqueous acid it is deprotected, and we again get our alcohol. Actually, when we form this THP, it is deprotected by aqueous acid, and its mechanism is like when this THP react with H plus from that aqueous acid, this oxygen get this hydrogen and forms such derivative. Then this oxygen remove alcohol, and we get that alcohol, and this group is removed. Such way that alcohol is removed. Okay, this is deprotected. In this video, we discuss about protecting groups for alcohols as a acetals and ketals as a protecting group. Now, so in second video, we discuss about ethers as a protecting groups. Now, we have to convert this alcohol into ethers. For the protection, we use some alkyl halides like benzyl chloride. When this benzyl chloride reacts with this alcohol, it forms such ether derivative, and this ether derivative, when react with H2 with catalytic hydrogenation like PD as a deprotecting group, it again give the alcohol. So for protection of alcohol we use benzyl chloride, and for deprotection we use catalytic dehydrogenation. By this way we can convert this alcohol into the ethers and again deprotected to get alcohol. Now when tertiary butyl alcohol when react with this alcohol, we get tertiary butyl ether derivative. This tertiary butyl ether derivative, when again react with aqueous acid, it again get our alcohol. By this way we again protected and deprotected the alcohols by producing ethers. For selective protection, when primary alcohol react with triphenyl methyl chloride. It is also known as a trityl. Symbol is Tr. It forms RCH2O Tr. This Tr means trityl. When primary alcohol react with triphenyl methyl chloride, it forms RCH2O Tr. This Tr means trityl. Again, when it react with formic acid or trifluoroacetic acid, it again get our primary alcohol. By this way, we can protect the alcohols by producing into their ether derivatives, and we can deprotect them also. So this way, we can protect the alcohols by forming ethers. Now, trialkyl silyl ether as a protecting group. Trialkyl silyl ether. We take the example of trimethyl silyl chloride. When trimethyl chloride react with alcohol, it forms this derivative ROSIMe3. This derivative, always remember, whenever we use the silicon group as a protecting group, always it is deprotected by fluoride ion. Okay. We also it deprotected by H plus aqueous acid. Okay. The mechanism for deprotection is when we take the fluoride ion with aqueous solution, this fluoride ion attack on this silicon and this RO group is removed. Then it take the H plus from water and forms alcohol. When it react with H plus, actually this oxygen lone pair carry this H plus to form such derivative. Again, there is aqueous solution, so water is always there. This oxygen lone pair attack on silicon and this alcohol is removed. This way we deprotected this silyl protection from the alcohol and we can get alcohols. So such way, trialkyl silyl ethers is protecting group for alcohol. This alcohol was converted into trimethyl silyl ethers derivative, and then these ethers derivatives are deprotected by H plus or F minus fluoride ions. Now, esters as a protecting group of alcohol. There are lots of derivatives. From this, we take the first derivative, formate ester. Formate ester is formed when alcohol is react with formic acid or some acid anhydrides. When alcohol react with formic acid or such anhydrides, they give formate ester derivative. This formate ester derivative cleaved by dilute ammonia or benzoate ester, we again get our alcohol. For protection, when alcohol react with 85% formic acid, it forms formate ester derivative. Or when alcohol react with such anhydrides, acid anhydrides in presence of pyridine, it again forms formate ester. This formate ester is cleaved by or deprotected by dilute ammonia or benzoate ester. This formate ester, when deprotect or cleaved, we get this alcohol. As we know that when alcohol react with acid, it always gives ester. This reaction is ester hydrolysis. So this is a simple ester hydrolysis. We get this ester, okay, and these are deprotected by dilute ammonia or benzoate ester. In ester as a protecting group, next is acetate ester. We have to produce acetate ester CH3C double bond OR as a protecting group for the alcohol. Means that alcohol is converted into that ester group. Okay, when alcohol is react with aceto means acetic anhydride. This when alcohol react with this acetic anhydride, it forms ACOR. Okay, or when this alcohol is react with acetyl chloride, CS3COCl, again this Cl and H is remove HCl, we get CS3COR. This is the protection of this alcoholic group. This alcoholic group is protected by AC. Here CS3CO means again AC. This is also AC, acetate group. Okay. Now deprotection. For deprotection, this acetate group is removed by 50% ammonia with methyl alcohol or KCN with 95% ethyl alcohol. These are the deprotecting group for ACOR. This acetate group is removed and we get the alcohol. Okay, this way we can deprotect this acetate ester. The next one is trichloroacetate ester. We have to produce from alcohol by protecting this OH group, converting this alcohol into trichloroacetate ester. For this, when alcohol is react with trichloroacetyl chloride, when alcohol is react with trichloroacetyl chloride, it forms trichloroacetate ester. Then this OH group is get protected by this trichloroacetate group, and when we have to cleave this, means for deep protection we use ammonia with in ethyl alcohol in the presence of chloroform, or KOH with MaOH, means potassium hydroxide with methyl alcohol. We can cleave it by ammonia in ethyl alcohol in the presence of chloroform, or potassium hydroxide methyl alcohol. Okay, this group is cleaved and we get that alcohol. By this way we can protect this alcohol. The next ester group is phthalate ester. In phthalate ester, when phthalate chloride is react with a primary alcohol, this is selectively react with primary alcohol generally. This primary alcohol is protected by this phthalate chloride and we get phthalate ester. Me3CCOOR. This is the phthalate ester. Now we have to cleave this. For this cleavage, we required the salt of tetrabutyl ammonium hydroxide Bu4N plus OH minus, or aqueous MENH3, methyl amine, okay, NH2, MENH2, methyl amine. This cleave this phthalate ester to form alcohol. By this way, we can protect this alcohol and cleave by these salts. Now, the last group for alcohol protection as a benzoate ester. This alcohol is protected by converting this alcohol into benzoate ester. This benzoate ester is we get from this benzyl chloride or benzoic anhydride. When this benzoic anhydride or benzyl chloride when react with this alcohol, we get benzoate ester. This benzoate ester is useful for the protection of this alcoholic group. Now, this benzoate ester can be deprotected by 1% sodium hydroxide with methyl alcohol, or triethylamine or methyl in presence of methyl hydroxide. By this way, this benzoate ester is deprotected and we get this primary alcohol, this alcohol. Okay, alcohol is protected by either this benzoic anhydride or benzyl chloride. We get this benzoate ester and it is deprotected by 1% NaOH with methyl alcohol or triethylamine with methyl alcohol. By this way, we can